My name is David Warner, and I'm a builder here in California. We have 35, 40 years of background in large scale and very, very high-end, sophisticated dwelling structures and institutional structures. And I've actually vetted many products coming into our green sustainability lineup that we can offer our clients and offer architects, and also improve sort of the nature of which and how we build with higher performance, lower embodied energy product lines. With cerlos, I've gotten very interested in how they have managed to take waste agricultural products with lignin-based product lines across the board, whether it's a raw bark or agricultural waste or paper products or cardboard products, and then create a slurry and use, in the vernacular, a continuous press using magnesium and phosphorus to create a incredibly durable board that is not only fireproof, which is really important in today's standards, especially in California with the threat of fire, but it also remains intact in water absorption, does not fall apart, and does not use a binding agent like you would see in an OSB or a plywood manufacturer in the UF resins or the PF resins, or in some cases the MDI, which is a thermal setting resin. It uses an added ingredients of magnesium and phosphorus to create a slurry that under heat and pressure then mineralizes those lignin-based product lines into a very, very durable end product. The end product to me is where it's all about, because these products have complete distribution, as we're looking at it right now, in the siding marketplace, exterior roofing marketplace, exterior wood decking systems, exterior molding systems, just to name a few, that are currently dominated in the same vernacular with a cement-based panel products. This product uses very low embodied energy. It's an exothermic product, meaning that it actually extends energy out of the process, which is terrific. And being on a continuous press, the line speed is very large, and I think it's a product of the future, especially now that they've figured out how to manufacture it. Magnesium and phosphorus on the human scale actually creates our skeletal formation of our bones in our body. But now it's being used to create the skeletal format of bringing agricultural into a product line. I'm holding up a product here that we actually took under the rigors of our own testing. And as you can see, we have torched it with an acetylene torch. We have cut it. We've drilled this product. Here's another section piece, a T&G with honeycomb in it. Same process that we tested it, performed extremely well. Then we submerged both of these products in a bucket of water, just doing the layman's test without any ASTM standards, which is probably a little more rigorous than what you would see from an ASTM in some areas. And we sunk that in water for a period of a week with no saturation after we weighed it dry to weight it wet upon removing it from the saturation test. I'm looking forward to working with cerlos as they move ahead with their product development and their plants. Their plants are small and a lot less sort of energy dense, and also on the size of the plant is much smaller than, for instance, a typical OSB or a plywood mill that is basically has to register themselves next to the resource. These products, since they can burn, or not burn, but manufacture with agricultural waste, can be sourced next to the areas where they're sourcing the feedstock. For instance, in the Central Valley of California, or near a bark distributor or chipper for OSB mills. These plants are small and can be set up quickly and start making high-end engineering products from what we would typically want to throw away and or actually burn, and contrary to our putting carbon in the atmosphere, and embodies it into a product that has length of time in structures. We are currently testing this product for use at MAHA, which is a large-scale city development in Northern California, just north of Napa. And we are looking to take it through the rigors of fire testing and also for the rigors of exterior weatherization processes for the use of exterior claddings on the buildings. The buildings have to be hardened for fire, hardened from exterior weatherization issues. It's a harsh environment. Sun, water, and freezing and thaw also occur on that it will actually go against the structures on site. So I'm super happy about its performance to date, and also looking forward to working with the company as they develop more product lines. Thank you very much.